make the molecule. The molecule in question is the FGLl, and we'll be talking about a lot about the FGL and the subset of the FGLl. And just to get into it, we'll go through. The FGL is what it stands for, the FG loop peptide, which is derived from mimicking the sequence of a neural cell adhesion molecule. A neural cell adhesion molecule is a membrane-bound glycoprotein, which is on the surface of glial cells. And so they're expressed with abundance early in development, particularly as you start to develop a lot of these neurological functions and increase plasticity. This peptide was produced to mimic this intentionally to be a fibroblast growth factor receptor agonist. And so these neural cell adhesion molecules activate fibroblast growth factor, particularly fibroblast growth factor 1, to activate neurite outgrowth, where developing neurons produce, new projections, and as they grow out in response to the guidance cues. So this happens, not just in development, but also in your everyday learning. One of the reasons that they say that children are a lot more apt to learn things is because they're much more responsive to the neurite outgrowth process, which is activated through fibroblast growth factor and these neural cell adhesion molecules. And so this has always been an area of drug development and relates to neurocognitive diseases, and definitely something which has gained a lot of traction in the most recent years due to some of these variants. I want to go into some of the research around this product as it relates to different indications. The first one is stroke, and there have been some really amazing studies on stroke with this product. Probably not to the level to replace some of the other products that we have, like the thymosin beta cerebrolizin for stroke, but still some really, really interesting things and maybe part of a protocol. And what we see here in stroke is that the FGL is able to modulate transcription of certain genetic regulators after the post-stroke process, the number one of which is sort of regulating apoptosis. What it can sort of do is shut down a lot of that apoptosis, causing neuron survival even in the environment, high inflammatory environment, following something like a stroke, and that includes hemorrhagic mixed strokes. In addition to that, it has some other transcriptional changes in the genome which help with post-recovery. So you can see, especially within the first 3 months of that acute stroke process, some improved stroke responses if you dose the FGL. And so this is just one of the areas that it has clinical benefit. The other area of clinical benefit is one that's frequently talked about as we talk about Lyme and some of those SIRS and chronic mold patients, where they have chronic inflammation of the brain leading to, a lot of that fatigue syndrome, a lot of just brain fog, as a lot of people describe it. This study looks at how FGL can handle and affect glial cells and their inflammation. And what we see is that it has significant anti-inflammatory effects and can even affect age-related changes in microglial cell activation and inflammatory cytokines. And it does that through a mechanism where it reduces the expression of CD200, which interacts with its receptor to maintain microglia in a quiescent state, which is exactly what we want. Proliferation, that overinflammation. And so for those people who, have a lot of the chronic inflammation, I think a lot of people would typically dose things like the RG3 in this case, maybe even some of the C-Link or C-Max. This would be another good thing to add to the arsenal as a nasal spray as well, which can really tamper down a lot of that inflammation. Other really, I think, interesting area, and next week we'll have a product called PE22-28, which will be a really, really novel approach to depression, one that can, take effect in 4 weeks or 4 days instead of, multiple weeks like some of those SSRIs. But the FGL also has a role in depression. Unfortunately, it really is only proven in a model where they show a decrease in neural cell adhesion molecules. But with that being said, that's not something that's typically tested for or shown neural cell adhesion molecule deficiency. And so this might be a way to treat depression in a lot of different patients. We really don't know yet, but it's still an area where that's worth looking at, because in this study they showed that in neural cell adhesion molecule deficient mice, there was a pretty potent reversal of depression after stimulation with this product. Now we're getting into sort of the two big areas that FGL are used in, and number one of which is Alzheimer's. This is where a lot of the money and the research is going to, and as I mentioned before on a couple of webinars, when companies like Pfizer and Merck are shutting down a lot of their neurodegenerative research, research departments, this is especially exciting. And so there have been a ton of studies in Alzheimer's, and this is where it started to gain a lot of traction in Europe, particularly in Denmark. And what they've shown is that in one mechanism of action, neural cell adhesion molecule is actually lowered in the hippocampus of a lot of animals, including humans. Amyloid can actually break down those neural cell adhesion molecules. Again, these are just glycoproteins that are bound to these neuronal surfaces, and whenever you have some of these beta amyloid plaques, you can see a decrease in the expression, which then leads to things like we talked about with that depression model, but also the for synapse outgrowth and survival. And so this is a really, really big target because we know beta amyloid affects those neural cell adhesion molecules, and in this case, particularly neural cell adhesion molecule 2. In addition to that, we've seen that in rat-induced models of Alzheimer's, by injecting some beta amyloid plaques, we saw that the FGL exerts its effect through an inhibition of the GSK3, which in turn a lot of microtubule stability, decreases apoptosis, and prevents neurite retraction, all of which would lead to improvement in cognitive function and less Alzheimer's disease symptomology. So this has been now mimicked in several studies. The one I just threw up here is probably one of the original, but some really, really good stuff. And now this is the FGL as a product is progressing to phase 2B clinical trials due to this Denmark company, and they're keeping everything pretty close to the vest. Lastly, and this is where I think most of our clinicians will probably find the biggest benefit, is its effect on memory. There's so much cool research out here about this, but in the fundamental difference is that it changes how these synapses form and produces, instead of outgrowths of thin spines, into sort of what they call mushroom spines. And mushroom spines have been thought to occur during physiological plasticity, so it increases plasticity, increases learning behavior, and has some other changes as well. But the mushroom-shaped spines and synapses have been known to be responsible for long plasticity, sort of the fundamental sort of turning point in memory. And from a mechanism standpoint, this has also been proven in even human models, increasing spatial memory, increasing sensory motor development, and just again performing, especially for age-related memory impairment, some really, really amazing results. And so the FGL is, like I said, one we've been trying to create and make available forever. We're not the only ones. It was awarded a $60 million grant in Europe in 2016 for further exploration, and they're definitely doing that. Since then, that was currently a phase 1 study before they got that money, and now they've progressed it, like I said, to phase 2B. So some really, really exciting things. The Fcl dosing is unfortunately something that is still a little bit difficult. The dosing that they were using in some of these clinical trials was intranasal dose, and they were doing anywhere from 50, 100 milligrams intranasally per dose. Unfortunately, we can't, the price of the product to create is just exponentially high to do with those doses. And so we've had to be a little bit inventive, and what we've decided to do is essentially offer 50 milligram vials. And by doing this, we're able to offer a subcutaneous dose, which is really as high as we can go. And this sort of helps us, again, hit all those physiological plasma levels and affect change, still maintaining some cost consciousness. And so this product would be a 25-day supply if you inject it at 0.25 mLs, which would be equivalent to 0.5 milligrams. And so far, we've only had a few patients on it. It's an interesting product, and I think a lot of faith in it. It's a matter of if we can. In fact, I think a lot of your patients, those who have age-related memory impairment, would definitely improve from this. And then the other people who I would say the big patient population who improve would be those who are experiencing cognitive-related decline and brain fog as a result of some of those inflammatory illnesses, such as SIRS or Lyme. And so that sort of wraps up the FGL. I'll definitely accept questions closer to the end, but it's one I'm extremely excited about. Optimization patients, to your elderly patients, to your diseased patients, your cognitive decline, definitely one to consider. And I would even put it up there with dihexa and cerebrolizin in terms of its power to affect change. The next product I want to talk about is an interesting product for us because it's actually not a pharmaceutical ingredient. This one can be provided over the counter, but such amazing results with it, I definitely wanted to let everyone know. And so this product is called, first, before I talk about the product we're offering, I want to talk about its derivative, or where it's derived from, and that is a product called hinokiol. Hinokiol is a phenolitic compound that is actually derived from magnolia bark. It's been used traditionally, although magnolia is very, very common in the southern United States, or the Southern America. It's also very, very popular in Southeast Asia, and it's been used for a long, long time in a lot of different things. Particularly, the number one thing it's usually associated with is reduction of anxiety, but beyond that, it's been shown to help with pain, it's help with cerebrovascular injury, epilepsy, and cognitive disorders such as Alzheimer's. And so it's one of those things that has a lot of pleiotropic effects. It's been used as a sort of homeopathic remedy for a long, long time. And so I've just included a couple things here about how it works. And again, it's very, very pleiotropic. We see in the mechanism to the right, you can see all the augments and preserves, such as ATP function and mitochondrial preservation. And it inhibits and blocks a lot of the things we would want to block, such as like glial cell activation. And so I've listed sort of everything here. And it's been studied in stroke through its inhibition of NF-kappa beta and can prevent leukocyte infiltration into glial cells due to that blocking of glial cell activation. In addition to that, it has a little bit of nootropic function, as it's been just like the FGL, but not nearly as potent. Been shown to cause neurite outgrowth and have neuroprotective effects, and particularly by increasing the cytoplasmic calcium. And then it's also been shown to help with seizures, again, by sort of limiting the high concentration of calcium that exhibits that excitotoxicity in ALS, Parkinson's, and epilepsy. And then, in addition, it has a lot of studies on sleep, where it's been found to shorten the latency period for sleep and increase the amount of non-rapid eye movement sleep, but not have an amount on, any REM sleep or EEG power density. And so it has a lot of just different which make it, sort of adds truth to a lot of those homeopathic remedies. In addition to all of those, and the main thing it's touted for is its ability to help with anxiety. It works in the same way with the GABA A receptor agonism that's been shown with almost all the benzodiazepines. And so we know that it, even just hinokiol itself, has a higher selectivity for the GABA A receptor than almost any of the benzodiazepines. And so that one already, it's exciting for a reason, but the issue is potency. As hinokiol itself, it might have some effects, but the effects are going to be minor and probably not worth paying attention to from a clinical perspective. But with that being said, there's a study on the right where they look at the different variants of hinokiol, and one in particular stands out, and that's the one that we're offering. It's called DHH B, and again, this is not a peptide, it's just a small molecule drug, but exists with a much, much, much better selectivity profile and strength than hinokiol, and it's called DHH B. So it has similar anxiolytic activity as a diazepam, but much less motor and respiratory effects, and it's not regulated as a controlled substance, all of which gives it a pretty good profile. And I included a little quote here that says, during the course of these studies, it was observed that 1 milligram per kilogram of diazepam produced muscle relaxation and mild ataxia. However, neither hinokiol nor the analogs cause any motor dysfunction. And so, again, we get all the benefits without any of the problems. With that being said, there are a few things to worry about from a dosing mechanism. The typical dose we suggest for the DHH is anywhere from 7.5 milligrams to 15 milligrams. Effects are felt pretty immediately, usually within 20 minutes, and it lasts for around 3 to 4 hours, with peak plasma concentrations being on around 3 hours. And so you can see that here on the figure to the side with that paper I mentioned earlier, where we see the results being highest at around 3 hours and then gradually decreasing. And the other thing is, to go into a little bit more of the study, the maze activity time was how they measured anxiolytic benefit, and you can see that in the previous one, we're just about the exact same on the diazepam and the DHB, and so it really is equivalent to the benzodiazepines in terms of strength, and it doesn't have nearly as much side effects So, but whenever we go into side effects, I definitely want to mention that just like with the benzodiazepine, there's absolutely no mixing with alcohol. You know, although it does have less motor and respiratory effects than the benzodiazepine, there's not been enough research to say safe and adequate levels, so it would be an absolute contraindication. And then additionally, just to be safe, we say that it also might provoke sleep. We know that the Hinokiol has decreased latency period, so it should not be used in situations where staying awake is safe. And so with that being said, we're rolling both of these products out. They're already in our formulary and available. If you have any questions, I'd love to take them now. Yeah, and with that being said, I'll also be sending out all of the literature on both of these products, as well as the literature and PowerPoint presentation that I gave right now. So with that being said, if anyone would have any questions, they're more than welcome to say something on the chat. And if not, I'd be happy to answer questions via email anytime tonight or tomorrow. Okay, well, I'm not seeing any questions, but I appreciate everyone for their time. We'll be sending this out, and if there's anything else that we can do, just feel free to give us a call or email. And I do see one question before I say goodbye, and that's any tolerance to, I'm assuming that's to the DHH B in terms of its anxiolytic benefit. We have not seen it to date. Traditionally, though, we've been doing some low, we haven't done a whole lot of patients. We probably have around 25 patients who use it relatively infrequently. This isn't, so far today, we haven't seen anybody who does it on a daily basis. But for those patients we have had, there's been absolutely no tolerance. And if there's any more questions, I'd love to hear it. But so yeah, I see another one that says, what is the best peptide now for Alzheimer's? That's difficult to say. You know, I think that the dihexa is by far the most potent and powerful neurologic product we have, and its effect on Parkinson's and Alzheimer's and a variety of EDs probably make it the go-to product for some neurodegenerative that's as powerful as Alzheimer's. If you can catch it early in the process, I think that it makes sense, particularly if you know it's a genetic A4 variant, to do something like the cerebrolysin. But I think the two probably best products for Alzheimer's we have in our arsenal now are going to be the dihexa and the FGLl, slightly behind that, and then the cerebrolysin more as a preventative measure. There's been no study, I see another question as well about neuropathy. There's been no studies currently linking the FGL to neuropathy. And neuropathy recommendations are going to vary, I think, by the type of neuropathy. We know that the thymosin beta-4, for instance, is great in vascular neuropathy. We know that the cerebrolysin has a really good neuropathy profile in general, and we know that the IGF-1 might help in some of those more compression-related neuropathies. And so it might be worth considering. I also see the question about restless leg syndrome, and unfortunately, I have no data or prior experience with any of these to sort of speculate on that. I definitely will look into that in terms of mechanism and see which product of ours might be the best, but currently I don't know that we're treating that with any of our products. And another one I want to mention for the neuropathy as well would be the GHK copper, the BPC. Both have had some nerve repair, not necessarily the pain felt neuropathy. For some reason, and this is sort of an isolated study, the GSI has some really good data in complex regional pain syndrome, as well as just a idiopathic neuropathy, and so that one might be something to consider as well. And so I appreciate everyone's time. Like I said, I'll be sending out a lot of information after this, but if there's anything else we can do, just let us know. Thanks so much.